if it's gonna obscure the apparent location of things due to refraction, then it's not going to be just even keeled across the board. You're going to have variations and differences, right?
Yeah, but
which is gonna make that Big Dipper, right? That specific constellation look contorted. It's not going to look as you know it to look. I've never seen the Big Dipper not looking as I know it to look.
All right, can I say two things? First of all, I think Danny was trying to get in. So if you wanted to, Danny, you can go ahead. I know you were trying to get in before. And then also, I'm posting the video. This is time-stamped right when Angling Alchemy brought up the Celestial Theodolite to MC Toon. And so I think I found the part. So if anyone, just to you guys, if anyone wants reference to what we're referring to, it was last night MC Toon was in here. And so that should be time-stamped around where Angling Alchemy started. When he brought up the Celestial Theodolite, and then I came in a little bit after that, and we had a whole, like, I don't know, maybe 30, 45-minute discussion on it. So just for reference, if anyone wants to see it. And then I think, Danny, if you were trying to get in as well, those are the two things I was going to say.
Well, earlier somebody said that atmospheric refraction was less at night, and that's not true. It's about the same day and night.
yeah, technically it's the temperature variant, right? It's a temperature difference.
And I think you're confusing it with terrestrial refraction. Terrestrial refraction occurs in layers very close to the ground, but atmospheric refraction is through all the layers of the air above, through which the light from astronomical bodies must pass. And that is due to changing density and temperature in the air above. And that stays relatively constant day and night. A lot of people don't know this, but if you go 200 feet up, I'll see on the air temperature from noon to just before dawn. It's the same temperature just about, because you don't get a lot of ground cooling and heating affecting the air up there. So the air above us, all the way up, is pretty stable. So atmospheric refraction is constant. Furthermore, I think in this discussion you're assuming that atmospheric refraction is far greater than it is. It's about a half degree on the horizon. But if you had two stars close together down near the horizon, they're going to be refracted by about the same amount, and you're not going to be able to see that with the eye very well. Now, in a lot of work I do, we take photographs of small star fields all night through a large telescope, well, medium telescope, and it tracks very well with the mount. But throughout the night, as the altitude of the stars change, we have to tweak the pointing of the telescope largely because of atmospheric refraction. It's greater because you get lower in the sky, and it's zero at the zenith.
But Danny, real quick, hold on. Couldn't we have aren't constellations pretty big in degrees? So couldn't you have one that's like a lot of degrees apart, or no? Like, what's a big constellation that would set?
Well, Orion would be one that you might notice. And if you looked at some of the brighter stars, their positions vertically might differ by 5, 6, 7 degrees. But one of them down to the horizon, its position is going to be refracted by close to a half degree, and the one above it is going to be refracted by maybe a quarter of a degree. And I don't think you're not going to see that to the eye. It's just not going to show up.
Hold on, Jeremy. I wanted to say something. So as that constellation approaches the horizon, we should see a change within the stars' configuration between each other. So if you're going to use Orion, then as that first star that gets closest to the horizon should have a noticeable difference in separation to the next star, and so on and so forth.
You're seriously overestimating the effect of the refraction. It's very small. As I said, on the horizon, it's about a half degree. You get up a few degrees, I have to calculate it, but it's a bit less than that. And you're just not going to see that with the naked eye. Furthermore, you have what's called the moon effect, the moon illusion. When Orion or the Big Dipper and the other constellations are low in the sky, they look much larger than they really are. Now, if you photograph them, they're not going to look any larger in the photograph because the camera's not fooled, but our human eyes are. I've seen this thousands of times. So how in the world you can see the real minimal effect of differential atmospheric refraction given what's called the moon illusion, you're just not going to see that with the naked eye. You're going to have to take photographs and do some very detailed comparisons to see this.
Can I interject real quick? Danny, I don't think you're considering the eye in this, because you said degrees. What do you mean? Degrees of what?
I'm talking about the angular separation between the stars.
I understand that, but when we say degrees, we're talking about degrees of change, right?
No, I'm talking, well, if you draw a line to one star and a line to the other star, then it's the angle between those two lines.
And that's something that you see with your eye, right? Degrees.
And we can also measure that as well.
Yeah, but you measure them in degrees of what your eye sees, correct?
Well, no, they're measured in.
Well, that's why I said degrees of what.
Standard. It's an angle, as you have any angle. It's not a special angle. It's the same kind of angle you would encounter in trigonometry or in geometry class. It's an angle.
It's not a math problem. It's not a mathematics problem. You have to realize that when they say degrees, they're talking about degrees of change within the eye, and that's the magic of
360 degrees in a circle.
Correct. That's why the eye is the degrees of change from which we measure what we see.
I don't know what you're saying.
I don't know what you're saying either, Sin. But
I'm saying you're not understanding that your eye is how we see things, and your eye is also refracting the light that we see. Do you see what I see?
Okay, real quick, I got a question. So, Danny, you said that terrestrial refraction incorporates the variables of temperature and pressure, right? And the differences between those, and that affects like the variables in the formula, right?
No, you skipped over the important part. Terrestrial refraction occurs when light is traveling through just the lowest layers of the atmosphere, a few hundred feet up, no more.
I'm just asking, is temperature and pressure involved in that calculation?
Absolutely.
Okay. Why? So how can you incorporate, like, what is part of the celestial refraction formula? What variables are there, and how come there's so many different types of celestial refraction formulas?
It's the same variables involved. However, my point is that when you get above a couple hundred feet, the structure of the atmosphere does not change from day to night. Really, the temperature and density and so forth are about the same all the way up. I mean, it changes as you go up, but it's not going to change throughout the day at different points. That's the difference between terrestrial and atmospheric refraction.
But do you get my question though, right? Like, if you have to take into consideration temperature and pressure and terrestrial refraction, right, because it's near the horizon, then how come you're not taking temperature and pressure into account with celestial refraction? Because from what I've seen, well, real quick, and then you can answer. But from what I've seen is that it's basically just empirical observations, and that celestial refraction is basically added in as like a coefficient depending on what angle you're viewing the sky at. And it's basically like a curved fit formula.
It is because we don't have enough information. You're talking about many, many miles of air that it's going through. But my point is that as it comes down through that air, the density is going to increase as it goes down. The temperature is going to increase as you go down. And that is a fairly stable thing. But over the years, people have modeled this, and they've also made empirical observations and get a very good formula for atmospheric refraction. And it's not nearly as variable as terrestrial refraction is.
That's interesting.
And again, somebody was asking, do we have any evidence of changing refraction? And again, I've taken thousands and thousands of images in my research work of stars.
Yeah,
small
but
star
Danny,
field. They change. We have a bit because we're not pointing in the same direction starlight's coming, because the direction of the starlight has changed a little bit.
But Danny, I preface that with it being negligible at best, and you supported that and saying that it's almost merely detectable with the naked eye, let alone it's only changing half a degree at the furthest, most drastic point being the horizon, dude. So, and you even said yourself it's zero at the zenith. So
I think but when you're asking about constellations changing shape, you were seriously overestimating the amount of refraction taking place. When I work with stuff I'm working on, we're talking arc minutes of refraction, and the eye can really see top quarter of an arc.
So, oh, sorry.
Real good graduation though.
I got one more question for you, Danny. So
Yeah.
you basically said the most extreme refraction, atmospheric refraction, basically is about a half a degree, and that's near the horizon, right? So if someone were to invoke anything higher than 30 arc minutes of celestial refraction, would you consider that to be a little too much or suspicious?
If it's more than 30 minutes of arc, yeah, I would consider that rather large. And are you talking about light coming right in at the horizon?
Yeah, we're talking. Where I've seen that is basically 1 degree, off the horizon, or 1 degree, 2 degree off the horizon.
And what kind of how much refraction are you talking about seeing?
Well, in some cases, like Jesse Path of Light has claimed 47 arc minutes of celestial refraction for one of his observations.
Well, I said about a half degree, so that's within a tolerable range. It's a little high, but I might accept that. But anything approaching a degree, I would be very skeptical.
Yeah, me too.
And it's got to be right on the horizon, because as you rise up a few degrees, it decreases rapidly as you go up. It's the greatest refraction is at the lowest altitudes, and once you get up about 60 degrees, it's almost negligible, really, even with large telescopes.
Interesting. Have you been paying attention to the celestial theodolite presentations or arguments? Did we lose them, or am I lagging?
Yeah, you kind of broke up a little bit there.
I'm sorry. When that first blew on the scene, I looked at it. I have not really looked at it since then much.
For sure. I would definitely tune in next Monday if you get a chance. I would like to definitely have your thoughts and opinions on it.
Okay.
Agreed.
I saw Professor Parks just did a video on it.
What did he say?
Refraction.
It was like a short video, like an 8-minute video of him just like kind of sitting in his car. So it was just kind of like a vlog style.
He hasn't done a proper analysis on it. He just kind of stated his opinion about what it could be. I think he needs to take a proper look at it still.
I will tell you, the one impression I had when it first was blew on the internet a few months ago was I got the doing the atmospheric refraction of the light coming down to the thing that was obstructing. I think it was a building or something on the some elevation. Mountain peak. And then I got the impression, I may be wrong about that, but I got the impression that they, from that point down to the lower elevation, they were applying atmospheric refraction a second time. And the problem with that would be that's using the first refraction you're doing up on the mountain peak. You would be considering all the atmosphere above, but when you do the second refraction down to the lower level, you should only consider the atmosphere between those two elevations. You shouldn't do the full atmospheric refraction all over again, because then you're overdoing it.
That is good to know, and I'm going to remember you saying that. Real quick, I must have missed last night. Angling went toe to toe with McToon on the celestial theodolite. Have to listen to it.
Pretty much, yeah. Tuna DM'd me. He wanted to do a stream here, and he wanted to call it Grill Tune, which is kind of like the idea of people could kind of grill him one-on-one or whatever. So he was giving people like 15 minutes, I guess. So yeah, Angling had his 15 minutes, and he asked Toon to steelman the celestial theodolite. Toon gave his best shot at it, which I didn't think was a very strong steelman to say the least, but nonetheless, he did that. And then they went back and forth on it for a bit. And then when they were kind of finished, I jumped in for. I didn't really have a 15 minutes, but that was the longest I kind of went back and forth with Toon on it. So I went for 20, 30 minutes, and then it kind of tapered off into all these other things about angles to stars and all these other things as well. But yeah, the one I posted before it was time stamped. I pinned it to this channel too, to the live stream one. So that's pinned right when Angling asked him to steelman the celestial theodolite. But if you rewind back a little bit, you can hear the beginning of Angling as well. But yeah, we had probably about an hour discussion on it in total.
Heard that, dude. I heard you, and I heard Shire Fawn piping up, and I heard Angle and Alchemy take really good stabs at it and do really well. And I heard McToon try to struggle and dance out of it, and then try to talk to anyone else about anything else.
Pretty much, yeah. He kept trying to change the topic, and he changed it. He's like, well, because I gave that little example. I was like, so if you had two teams of people and you just gave the timing, the one team using the planar trig, the other team using whatever globe refraction you want, which ones would actually be able to get the correct distance, to derive the correct distance? And he had nothing to say with that. The only thing he derailed after that, he was like, well, what if we try to predict sunset times? He just jumped to another topic.
He was like, well, using what you just said, what's the height of the star? Can I detract that way first? Well, first, Angle and Alchemy gave him a good steelman and, outlaid it. And then he was like, okay, next. And you were like, whoa, hey. You were like, I don't think that was a fair representation. We should go back. And then you definitely gave him the outline and pinned him to the corner. I thought it was great. I thought that he was like, I don't know, Jesse and Ruhik took care of it already. I don't have to deal with this. That was pretty much his answer.
Yeah. Well, he kind of cut off Angling because he had his little 15-minute thing. He kind of cut off Angling. That's the thing. He was like, all right, Angling, see you later. We're done. And I was like, wait a minute. And then I was like, can we have a bit of an open discussion? Even he said no to that. And I was like, well, we just did it anyways. It was funny.
Yeah, he was like, can we do this? He was like, no. And everyone was like, okay, well, we got to talk about this. You can't just skate past this and not address the biggest evidence around at the moment or whatever. You want to talk about angles to stars and flat water instead?
Yeah, Danny, I'm just curious. Do you think you can kind of lay out the premise of the CELTHEO? So you said you saw it originally. If you want to, you don't have to, but I definitely want your take on it because you are an astronomer.
Well, you're talking about the experiment with the celestial theodolite?
Yeah, if you want to try and give a steelman real quick, I'm just curious, and then if not, and then I'll fill you in on the stuff you missed.
My recollection was that you had a star setting, I think, over the Rockies, and this person was in the land close to the base of the Rockies, and as the star was setting, the peak on top of the Rockies was on a slope on the side from his house that he was able to do pretty well, and he timed, I believe, with a telescope when the star was blocked by that peak, and then applied atmospheric refraction to get the angle coming in at that point. But then he then reasoned that the light right at the instant it was about to be blocked would be refracted a second time down to his location, which is correct. It would be refracted a second time. And my concern is that he calculated, overdid the value of that second refraction. That's basically what I recall seeing.
It wouldn't be too bad, but I don't know about this adding in refraction a second time from the peak to the observer. I'm not really sure what you mean by that, but yeah, that was a pretty good seal, man. That's not bad. But essentially, oh, sorry, go ahead. You're robot.
I just said I tried to be honest about this. There's nothing to be gained by misrepresenting what people are arguing.
No, you're good. You're good.
I wish you could tell all the other people that.
I wish I could too. There's a lot of that going on, and I don't like that.
So, do you think it's an interesting idea? Let's just say that you would basically use the occlusion angle timing, right? So there's only one time, right, where the observer actually sees that star disappear behind the mountain. Bam, take a snapshot of it. And then you have two different predictions for, you have two different calculations essentially to derive your distance, based off of the height of the mountain, right? Because if it's a globe, then you would have, a different elevation height of the mountain peak because it's supposed to be tilting away from you. And then if you have plane trig, then it would just be the height of the mountain. And then what you would do is you take that angle and then the height of the mountain, and then you derive your distance and you see which one is closer. Do you think that's an interesting concept? Like that's to see like what,
I think it is very clever. I see two problems. Number one, it relies upon a lot of computation of what the refraction ought to be, and there are variables involved there. We generally end up taking average values. And the other thing is precision, how precisely you can get that and how precisely you can measure those things, and can you get a really fair comparison. But I think it was a very clever, nice idea. I think it's a very, very idea conceived. Now, if it can practically be done is another question.
It has been done. Consistency.
Yeah, it's been done 46 times now, Shane.
Well, let me ask you this question.
6 different peaks, like 28 different stuff.
I got another question if I can ask. I've
absolutely.
I've been involved in the flat Earth discussion now for 9 years, and I remember back when we would mention refraction, usually talking about terrestrial refraction, for seeing too far, objects too far. When we would bring that up, flat earthers generally would laugh in derision, dismissing it, thinking we're just making up excuses and such. I don't hear flat earthers doing that anymore. In fact, I see flat earthers attempting to invoke refraction on their own. I think it's an interesting change that's been made over the past 9 years.
Well, I think that our position with refraction has been that previously it's been used as like a blanket of unfalsifiability applied to any terrestrial observation at sea level that would magically bring it back to be coherent with the globe, right? No matter the distance, there is no coefficient for refraction that you guys would apply that would bring that, observation that's too far on a globe to be refracted just up enough to be seen on the globe. So I think with the celestial theodolite and with recent sort of discussions where we're trying to make the prediction with refraction, right? We'll allow terrestrial refraction and celestial refraction to be applied with your prediction, and then we have to hold you to that prediction when we try to do the calculation to get the distance for the peak and the elevation above sea level. So the whole thing with refraction is before, when it wasn't being used to predict, it could just be endlessly applied post-diction and applied to anything to make it go away. And now with the celestial theodolite and other observations, we have to make, a prediction with it. And it turns out now, no matter which form and type and amount you apply, it's never consistently enough. That's what we're finding.
Yeah, Danny, you would definitely be intrigued by all the update to the celestial theo argument since you heard about it a couple months ago. It's just been getting fine-tuned ever since.
I didn't know that Rob Parks had addressed it. I like him, and he knows his stuff really well. I think I'd like to check out what he says first, and then go look at it myself.
Well, that's unfortunate because he made the same mistake. All he did was watch Ruhif and Jesse's, and then he commented on that. He actually didn't investigate it whatsoever. And we like Professor Parks, but we're grilling him hard for not investigating it at all and throwing out an opinion piece. If you would
I didn't see the video,
same,
so I don't know. I don't know what he said.
That's not long. You can definitely watch it, but you'll see he says right away, I don't know much about it. I haven't looked into it, but here's what Ruhif and Jesse say about it. So.
Okay.
By the way, real quick, I think it was Sincleanser or somebody else was saying that, looking, you're not actually doing any measurements of the sky, but couldn't you argue that if the sky is moving at a constant 15 degrees per hour, right, relative to whatever first position you measure or reference, wouldn't that constant basically be like, can you use that as a constant, like in terms of a reference when doing any other types of calculations based off that?
Yes, you can. One example I use is that a lot of the telescopes I use have equatorial drives on them, and when you put it in the solar rate, it runs at 15 degrees per hour. If you do the sidereal rate, it's a little faster than that, and they track very, very accurately if you have the polar axis correctly aligned. And I've taken the eclipse in last year. In 4 hours from before the partial phase began until after it ended, and they remained centered pretty well, and the thing was turning at the solar rate of 15 degrees per hour. I did the same thing with the lunar eclipse once on that, and what I did was make time-lapse videos out of it. And if the things in the sky were not turning, if the sun were not turning at 15 degrees per hour, then it would not remain centered in the frames, and it was centered very well in all the frames over 4 hours or more.
Interesting.
That's over about 950 photographs, I think.
So you think it's fair to basically use you think it's fair to basically use the geometric position? And what I mean by geometric position is basically, that star being at the angle of what it would be, after 15 degrees per hour off the first cusp of Aries, based on the vernal equinox, yada yada yada. Would it be fair to basically use that occlusion time and because it's a time where you can't see the star, it's no longer an apparent calculation. Do you get what I mean? Like, as soon as you can't see it, then you can basically say it's not apparent that matters anymore, right?
Yeah, I mean, what you're talking about is when that star is occluded, it's not in its true position because it's being subject to atmospheric refraction, and so it's going to. I'm assuming, atmospheric refraction, and it's going to have a difference in position. By the way, he said he's done it many, many times. Has he discovered the variability in the amount of refraction?
I would say, I mean, from what I've seen, it's I don't really understand the pattern of why certain refraction coefficients are used in order to get a certain amount of arc minutes, right? Depending on the angle to the horizon. I don't really see a consistent pattern. To me, it almost looks like it's like I said before, like a curb fit formula.
Yeah, because you're taking.
Right, cool.
Well, let me ask you this: you talk about the difference between a flat Earth and globe Earth prediction, dealing with this celestial theodolite. What is the nature of prediction different?
What?
Different is my question. Are you talking about just the elevation difference that you're talking about?
Well, they're able to use that. Go ahead.
Go ahead, Toby. No, you go ahead.
I was just going to say they're able to derive the distance to the peak using the angle that they get from the occlusion time and the height of the peak. So the difference there is that the flat Earth prediction is always ending up more closely aligned with the observation. The distance derivation is more accurate.
So Stellarium doesn't know where the observer is when we get the occlusion angle, right? So when we see that star disappear behind that peak, bam, we take a snapshot in time and we put the observer in Stellarium, the peak of the mountain, and are referencing the star from the peak to the star. So Stellarium doesn't actually know where the observer is. And then what we're doing is driving the distance based off of the height of the mountain for one prediction, the height of the mountain for another, and using the same angle and seeing the difference in distance. And which one is actually closer to where the observer actually was.
And So you're taking the timing of the predicted occultation of the star from what Stellarium says.
Observe the timing, convert that to an angle. So you move the observer to the mountain. At the mountain, that time corresponds to a very specific angle. Nature of the prediction is, for flat, we just use basic arctan rise over run. For the globe, you do a variation of that, or you subtract geometric earth drop and add in refraction, whatever the process is. But the point is, it results in a different angle that isn't the arctan rise over run. And those two predictions provide mutually exclusive evidence. So what we're comparing that to is the true position of the star at the time of occlusion from the mountain. So that's why we get our prediction. But then
so you're not concerned about the time of the event as much as it is the well, I guess I don't understand. Is it?
No, yeah, the time's important. Time's important because the time gives you the angle.
The time is the only thing that the observation is. Like, you're only observing the time. You're not observing an angle when you're making the observation. The only thing you write down is the precise time. And when you go into
But how is the time computed then? Predicted time.
I don't know. We're not predicting time. We're observing. We're observing the time that goes behind the moon.
Yeah, he's syncing it to a telescope through GPS. It's like a GPS sync. So I think it's like 1 frame per second, right? Something like that.
But then when you get your predicted angles, for Pikes Peak, the flagship example, the flat Earth prediction is like 231. The globe prediction is like 219. So what you do is you can then construct a second triangle using that known angle that you just computed, and either the elevation or the distance to compute the one unknown. And those are the comparisons that we make later to see which angle was more true.
Okay, I got to look at that to see what's going on. I'm not quite certain what the methodology is.
Danny, I've tried to get a straight answer on this, and it's incredibly elusive. Because they both agree that I can go out on any given day with a theodolite, and I can measure, from the observational location. I go with a theodolite, and then I can measure, the mountain peak that they're using, or whatever mountain peak they're using for the occlusion. I can go out with my theodolite and accurately measure the angle of that mountain peak. And then they also agree that the star is occluded. Like if we go out on a full moon night where you can see the silhouette of the mountain, which you can in some of the videos, they also agree that the star will be occluded the moment that the star intersects the silhouette of the mountain, which means that the star was occluded at the elevation angle of the mountain that we took in the daytime earlier in the day. You can also then go into Stellarium and plug in your location for the observer and add in atmospheric refraction, and Stellarium will accurately predict the moment of occlusion, and it will be, the timing of that occlusion. If you're using UTC, it'll accurately tell you at what UTC you're going to get to the angle that mountain peak was at that you measured. All of that completely conforms to the flat Earth. So I'm completely lost as to what they're trying to say with the celestial theodolite.
Hold on, Jake. Do you remember what Danny just said? So you basically just provided the example that Danny was talking about, where you're basically incorporating atmospheric refraction for the observer to the mountain peak, and then also from the mountain peak to the star. That's what Danny was saying. You're doing it twice. You're overshooting it with celestial refraction. That's why we don't care about the observer to the mountain peak, right? That's actually the control. That's supposed to be the unknown, right? And we're supposed to derive the distance, right? That triangle, from the observer to the mountain peak to the base of the mountain, right? That triangle is the unknown to Stellarium.
What's unknown to Stellarium?
Stellarium doesn't know how far away you are from the mountain peak unless you actually tell it. So if you tell Stellarium where you are, then yeah, of course you're going to get the globe answer. What we're doing is we're trying to compare it. We're trying to see if that's actually accurate to reality by using when the star gets occluded by the mountain.
what you're doing has no relation to what we're trying to put forth with the mutually exclusive output, right? What you're doing is what everyone does, looking at mountains for all of history, for all of recorded time, nothing to do with what we're talking about. But I do appreciate that you bring it up each and every time, and in that super slow.
I just I can't get a straight answer on it. That's the part that doesn't
Well,
make any
I've said
sense.
that to you
you
like 11
just got a
times.
straight answer. You got a straight answer. You just don't want to
Danny,
accept it.
Danny, you're an astrophysicist. Does that answer make any sense to you?
I'm not sure. I'm still trying to sort through this.
Yeah,
Somebody,
it's one of these. They're saying that it's literally a
Jake, this is
situation
Jake's
of being
answer. Hold on,
baffled
I'm
by
gonna interrupt
bullshit.
you, dude, because you keep doing this and it's really annoying. This is Jake's answer. Why not just take a theodolite to the mountain peak and get an angle? Because
The
that's not
whole
what the fuck we're doing.
Yeah, the whole point of making an observation of it being included is that it leads to a mutually exclusive angle. Taking a look and just looking through satellite and factoring in it isn't mutually exclusive, right?
What is
That's
the
off.
mutually exclusive angle that we're getting through the celestial theodolite? I don't understand.
Yeah, well, it's amazing that you've heard the 77 times. You don't understand,
It
but when
still
we're
doesn't
doing
make
a
any
flat Earth,
sense to me.
well, we're doing a prediction based on what we know, right? So we construct arctan, rise over run. We get the elevation. We know the distance. For that computes an angle. We get a prediction of angle. That's our angle. From the globe, you either take that angle, subtract geometric Earth drop, and add in refraction, or do your smaller triangle. Either way, it will yield a smaller angle because it has to be, different geometrically, dude. So you have a different angle. So what we have is compare the time at which the star was occluded to the one true angle. That's the comparison point. We compare
And then
both of
derive a
those
distance.
angles to that
Yeah.
angle. Yeah.
So you're saying that
I know you understand this, Jake. You just don't
I
want to
don't. I
agree
really
with it.
don't. I'm not. I'm really don't understand it.
I'm more
So
interested in
you're
trying
Okay.
to talk to Danny about it, to be honest.
Yeah, I'd rather talk to Danny, who's actually being good faith.
Danny is completely baffled. Also, I can already tell because he's in here saying like, I don't get it.
Don't
I
speak
haven't
for him,
studied
dude.
it.
No, he said he checked it out at the beginning, but he hasn't looked deeper into it. And then he just said he's going to look more into it.
Yeah, and Danny, please, I would love to have a back and forth with you, like on Monday if you can. Um, and yeah, the spreadsheet is going to have all the information on it, etc., and see the other observations that were made, as well as the different peaks, and then you can actually see the comparison of of the different predictions, or for flat versus globe, etc.
What was up with the video that Ruhev made about the J factor? And he showed that no matter what occlusion time you put in there, you'd always get the same answer. And all the data points showed the accurate elevation of the mountain to within, was it a meter or two, not taking into account whether the mountain peak, the star actually occluded at the exact point of the mountain peak, or whether there was a low-lying cloud or anything else, or trees or anything.
Yeah, that has nothing to do with the data as we went
Nothing
through
to
the
do with it.
process with both of the mutually exclusive predictions. What that was talking about was a data aggregation factor that Michael chose to employ after the fact in a response to the actual criticism that, hey, your data, your results are not entirely consistent. Why is if you're saying that it's real, why is the flat Earth not exactly point on every single time? And he went, oh, okay, let's correct the data. He used the globe observation point, computed it right to the actual globe predicted apparent to give the globe the maximum benefit of the doubt. And as a side product, when he did that data aggregation, it aligned the flat Earth prediction even more close to zero. So it took what was a deviation of about 150 to 200 meters and brought it down to 5 to 10 meters for
The
the flat
only
Earth prediction of
measurement
the
that's
elevation.
being
So what you're talking about isn't actually relevant to any of the predictive mutually exclusive angles that we just went over. The process that we went over was all inclusive. It included all the data. There's nothing that you need to do the computation that we left out. So what he chose to do with his J factor was actually named for Jesse because of his nonsense critiques. And of course, as soon as he critiqued it, then he corrected it to have it that consistent. The new critique was, well, now it's too consistent and obviously unreliable. So it went from that's not consistent enough to that's too consistent, and that's why we have this neat J factor GIF on and off, which shows that there's no mutual exclusive changes when you apply the so-called factor, and it also is a post-diction, has nothing to do with the prediction. So.
he showed that the only observation that's being done is the timing of the occlusion. That's the only measurement that's being done, right? The only thing you're entering into the spreadsheet that's data from your observation is the time of the occlusion, right?
Which is never adjusted for any of the predictive data. Exactly.
That is the only input that's in there is the occlusion time, correct? That's the only measurement that's being done and inputted into the spreadsheet as the data source of the observation, correct?
Yep. Observation is of the time.
So,
Yep.
so why is it that on that spreadsheet, regardless of whatever time he put in for that occlusion time, it always gave the same answer?
Because they don't know how Excel is set up and they have it misquoting other cells.
No, that was Alan's sheet. We're talking about the Heffron sheet, which is what
the Heffron sheet.
What Ruhif was featuring during his nonsense thing. And it's the J factor, right? He had a drop down menu where you would apply this post prediction data aggregation technique, which is being displayed in chat right now. You see how all the predictions are still closer to flat Earth, both with it on and with it off. All he was doing was correcting that. So what his sheet was doing there is just aggregating that data and pulling that factor off and on. You can definitely see doesn't move any of the mountains, any of the peaks closer to globe than it does flat. Flat is still within 200 meters of every prediction, like I said.
What was Jake saying?
Danny, did you have anything else you were going to add before? I think Jake had kind of jumped in over you.
Well, just, I spent the last few minutes looking at some of the things that the figures that you and Shane St. Pierre put on there. So let me try to phrase this the basic guy. It comes that mountain peak is far enough away on a spherical Earth that the top of that ought to be a little lower than it is on a flat Earth. And so when you look at it on a flat Earth, you're measuring your angle at the observation point, and it should be the same angle that the light is striking the horizontal on a flat Earth at the top of the mountain peak. That's just simply a act of geometry. You got two parallel lines with a transversal opposite interior angles there. On the globe Earth, the mountain's going to be a little lower, and so you've got a different angle. I think I got the basic gist of what's going on. Now, my question is, where is in the flat when the computation is being done? Where is action being? What's the point?
Here, what was the last part?
Yeah, I think you broke up a little bit, but I think he asked when does the celestial refraction get incorporated? Right? Is that what we asked?
Yeah, I'm looking particularly at the one that Geo posted at 7:13 p.m. Eastern Daylight Time, and see the angles there, and the angles are different between the two of them. And then when I look down at a couple of Shane St. Pierre posted two of them there, one at 13 past the hour and one at 21 past the hour. Both of them have a atmospheric refraction referencing their G.G. Bennett, and I'm asking where and how and why is that refraction calculation being applied?
Well, it's for the globe. We're giving the globe the geometric Earth drop subtraction via whichever formula you're most comfortable with, 360 times the distance over 2 pi r, or the d squared over r squared, whichever metric you want to use to compute the difference. On the flagship example, it's always like 201 meters difference. So whatever way you want to use to compute that. And then on top of that, you add in the celestial refraction for Bennett for observations below 15 degrees. That's for the maximum benefit of the globe. And it's being applied mostly in our example in the Heffron method. It's being applied straight to the flat Earth prediction to yield the globe Earth prediction.
Okay, I see. So it's on that one put it at 13 minutes past the hour. There's an angle of 50 arc minutes there, and an angle above that 1 degree and 3 arc minutes. So a 13 arc minute difference between those two.
Yeah.
Okay, so you're applying atmospheric refraction.
No, that we're applying celestial refraction to that one, and we typically don't apply terrestrial to the globe unless we do it the Ruhip method, in which case 2.4 arc seconds per kilometer ought to do. So on 50,000 ends up being about 2 arc minutes. That would bring it to about 52 arc minutes versus 1 1 degree 3 arc minutes, and again, the
You
actual
shouldn't.
is over in the left, the
You shouldn't
101.
apply. You shouldn't apply terrestrial refraction. It should be atmospheric refraction, or I think what you're calling celestial refraction. So I got to think this over and look at it. I don't think I'm prepared to just make a.
No,
big
I
judgment on
totally
this.
agree with you,
Oh,
Danny.
that's cool.
I totally agree with you.
Questions are good.
There should
I
only
can
be
see getting it.
there should be only one celestial refraction formula used, and it should be from the peak to the star, right?
Yeah, I agree. We
Danny?
shouldn't apply terrestrial refraction. That was his first take. That's our take as well.
Yeah, exactly.
That-
Because we don't know the
that-
temperature and pressure between us and the mountain peak. There's no measurements of temperature and pressure between us.
Yeah. And I don't know what the point of doing the correction. I mean, the correction for atmospheric refraction there anyway, because you're taking the observed angle, and you don't really need to know what the unrefracted angle of the star would be, because you're not going to observe that anyway.
I love you, Danny. Love you, bro.
I don't quite
Exactly.
understand what the point is there. Unless when refraction's applied, I was thinking that you were taking the calculated position of what the star angle should be, and I can do that pretty accurately, ignoring refraction. Now refraction changes everything. I just didn't see what the point of doing the you're merely, it doesn't matter to you if it's been refracted. If so, how much?
What?
Yeah, Danny, you're having like about every 3 minutes, you cut out for about 10 seconds. So it's like it's right at the prime part that we want to hear the completion, and so you just dropped out the last 10 seconds. If you could repeat the last part.
The last thing I said is since you're not really calculating the position the star has in the unrefracted sky, you're simply observing where the star is. So it doesn't matter. I think it doesn't matter if you consider atmospheric refraction or not, because you're simply observing where the star is.
Oh,
Yeah,
dude,
that's
isn't that great to hear? Isn't that so great to hear? Like an actual good faith, honest person. Oh, you guys don't care about refraction. You guys don't calculate it in. Oh, these guys don't think refraction is real. Dude, Danny, you're a breath of fresh air, bro.
But look at only when there's good evidence that it's either A, happening, and B, is important. In this case, it's happening, but it's not important.
Also our determination,
Exactly.
which is why we go through the trouble of adding in that 2 arc minute for this example to show exactly how important it would be and how it's unproductive to change and yield a different result. So,
Okay, Shane, can I ask you a question real quick? Maybe?
Is it going to be the volume of gravity for the Earth?
No, it's more
Okay.
related to what you guys are presenting. When you use these standards of measurements like arc minutes or degrees, what are you basing any of these measurements on?
What?
Like you said, arc minutes and degrees. Where did you get those measurements?
Units of a circle, right? Measurements, optical degrees, metric system.
Well,
from the meter
optical
convention of
degrees,
1886.
all degrees are optical,
Okay.
right?
What was
So-
Jake saying about the stellarium timers? Yeah,
So, I mean, the argument is about how the eye sees something at a distance, right? So we'd have to understand
All degrees
that
are not
it's
optical.
No, it's not about that.
Sorry.
Actually,
all degrees are optical. That's how we see with the eye. It's
only thing
degrees
you're
of what your
using
eye
is-
sees.
the only thing you're using is when not the only thing, but in terms of the optics, is just when the star occludes. So when you're no longer able to see it. So you're not using your eye to measure angles with this. You're just doing.
Yeah, well, you are though, Gio. Like, are you closing your eyes to measure it?
or camera?
You're not measuring it with your eyes. You're just watching the star occlude, and there's a time to that.
Okay, how do you watch it with your eyes closed, Gio?
With a camera.
Okay. Well, the camera's gonna be based on a 360-degree area, and that's what we base the eye off of, though.
Did you have a contention
You
or
could-
like a question on the method or?
You could see in any other form of like geometry. You don't need perspective or anything. Like you could see
So
in any
you're-
other version and still see it occluded. So it's really not to do with any quality or characteristic of the eye whatsoever.
Okay, but you guys realize that the celestial theodolite people are claiming that you don't need to use your eyes to see something. All I'm saying is
No one's
caution
claiming
yourself on
that.
that. Hold on real quick. All you're saying is that we don't need to see something to say it's apparent. That's not a really good argument at all, in my opinion.
All right.
I don't know what the fuck you're saying.
Thanks.
I know you're not
Anyways,
understanding because you're not understanding that what you see is apparently what you see with your eyes.
Yeah, no,
but
okay.
That's just the
cool.
observation. That's all you're saying. There's an observation.
Yeah.
Okay, we
All
get
I'm
it.
saying is you have to see something to measure it.
All right, let's say we see the star get occluded by a mountain, right? And then
You
we
can't
mark
do that
down the
because
time.
you said you don't need your eyes.
You technically
That's a great
you could
argument.
All right. This is fucking retarded. I'm out of here.
Well, I'm not trolling you. I'm just saying there's a flaw in your argument because you don't even
Troll-
There's
consider the
not
eye.
Sincleanser. You're making yourself.
Okay, you
Trolls
can all
sound like-
dogpile. You can all dogpile, but you can't
What was
refute what
Jake
I'm
saying?
saying. That's the problem with you guys.
What was Jake
And I'm not
saying?
being hostile. I'm just saying there's a flaw in your
Who
argument.
cares?
What
Well,
are
you don't
even trying
care.
to
That's
say?
why I'm saying to the people that do care, they might want to
All right.
consider this when, yeah.
Yeah, but
You can make a
what are you
measurement
saying?
with the device. You don't need eyes. A blind person
Okay,
could
so
do
you
it.
measure things with your eyes closed. Is that what you're saying?
A blind person could do it.
Okay,
You
well,
could
how did a blind
technically-
person? Okay.
Yes, you could build a device that only picks up light that doesn't even have a lens, and you could technically detect when the star is occluded without eyeballs or a camera if you wanted to set a device up.
Well,
that could
that's
do-
not a. Yeah, I don't. Good luck.
A blind
I
person
just,
could do it. It could be
I
a
would never
camera.
go that direction.
When the star is
personally.
occluded, it could vibrate, and that's how you know the time. And then the time could be spoken audibly for you.
Okay, are you guys understanding what my point is, or are you just dismissing it?
We don't think
I don't think you
a
have
You're
one.
saying you can't.
No, we
You're
heard it.
saying-
We heard it. We all agree.
Can you
It's
steel
great,
man
it's
my
noted.
argument for me, just for posterity's sake?
Yeah, you have an
Saying you
observation.
can't take a
but
measurement
you're
without
using
eyes.
I'm saying that I would never measure something without looking at it.
You're saying, boo, you don't like the celestial satellite.
Okay, but there's devices like there's parts of the electromagnetic spectrum that you can't see with your eyes, and we can still detect and measure those.
Yeah, but you'd have to open your eyes to measure those.
What does that
Why?
have to do though
What?
with anything?
Because
It's
even
an
if you had a tool, hold on. Even if
You're
you had a
observing
tool that did it
something.
for you, you'd still have to look and read the tool, dude.
No,
Okay,
Why?
so
It
you're
could just be
observing
audibly.
something.
It could
All
just.
right.
Oh
be
yeah,
spoken
maybe we can
audibly
just
to you.
telepathically know everything. We don't have to measure anything, right? Like you guys are doing.
You ever heard of
This
text to
is-
speech?
Do you
So
think
when the results are in, you can have a text to speech program just read
I'm just
the
saying,
results.
consider what I'm saying. That's all I'm saying. I'll bow
blind
out.
people
Consider
considering
my
it, but-
argument. Here.
can blind people never measure anything?
Thanks.
I've never
Can
seen
we-
a blind man measure flat Earth. No.
We were on kind of.
Oh,
a-
no, that's not my question.
Right.
My question to you was, can a blind person ever measure anything?
Yeah, but this is
Alright.
just a huge derail from the conversation.
Yeah, it's a
man.
huge derail. Can we go back to? But thanks, Sincleanser, for that. But okay, can we just confirm that Danny actually was completely like intellectually honest about the point on refraction that most of the other globe community seems completely hung up on?
Awesome.
Well, I mean, he cleared it up for me when I asked him originally and said refraction, celestial refraction at nighttime, looking at stars is negligible. And I mean, he agreed with that. He said it's, what did he say, a half a degree or something at the horizon? Is B still in here? Because I think he was here when he heard it, but something along those lines. It was like almost nearly non-detectable with the human eye.
I don't mean this as an attack on Danny's character at all whatsoever. This is just a prediction from what I've seen of, in general, people, globe proponents when encountering this discussion. Like, I've seen a lot of honesty from people. Like, I saw Jesse admitting a lot of numbers were more closely aligned with flat Earth and early on, and he was kind of perplexed by it. And then now he's kind of gone from the discussion months later. I think Ruhif kind of agreed to the methodology originally, and now he has issues with the methodology. I'm going to make a guess that there's a chance that, actually, I shouldn't say this about Danny, but just in a lot of cases, people will initially be sensible about this discussion and say things like, yes, let's use a normal refractive index and not apply it twice or whatever. But, once they start seeing the numbers and the numbers don't comport to a globe, the question becomes, will they, take the null of the hypothesis into consideration?
Or could it be that just over several months they look into things and they read documents and they read like mathematical models and they do a bit of research and they realize, wow, I wasn't actually an idiot for believing this like 2 months ago. Now that I know more, I'm changing my opinion. It couldn't possibly be that, right?
Listen, you're the guy that basically argued about using the word occlusion. Like, oh, that's
Yeah,
a
it should
dental
still be
term.
obstruction.
Yeah, you guys
Yeah.
suck and do everything wrong. You don't know how to use spreadsheet. I don't have a contention, but everything you do is wrong, and I know that. Hey, well, when we're applying celestial refraction, who said it was negligible? I mean, I agree that it probably doesn't matter, but in the distances we're talking about, for Pike's Peak, it's like 15 arc minutes, right? So it's not, it's it's mutually exclusive determinant. Applied either way, that could be we have a threshold maybe of 15 arc minutes. So it kind of is important, but that's the only one that we typically allow is celestial refraction at distance. And then they like to add in terrestrial, but again, doesn't help. But yeah, I don't know. I don't know if it's negligible.
You guys heard it from Danny, dude. He's like, why would you need to apply celestial refraction between the observer and the mountain peak when you can't see the star anymore?
Right, because it doesn't behave like it does.
Oh, but wait, Dyslo's trying to get in.
I was just gonna say real quick. From what I heard him say, he's like it's refraction zero at the zenith, and it only increases towards the horizon. And from what I made sense of, it maxes out at a half a degree. So I don't know where you're getting. I don't know what the conversion is between your 15 arc minutes and a half a degree, but if that's a huge variant, then we might need to further discuss that with Danny.
We say
half a degree is 30 arc minutes.
It's just R equals 1 over the tangent.
So it's even smaller then. It's even less negligible.
It's used right in the it's right in the formula, right? When using G.G. Bennett, it's R equals 1 over the tangent of H plus 7.31 over H plus 4.4. Those are the two constants that we were talking about earlier. And that H is just the angle that we're talking about. So you plug in the globe angle there, and that's what gives you the 15 arc minutes for angle of, in this case, let's say 217.
If you know so much about it, why you didn't understand the other guy's question?
It was a poorly worded sentence.
What?
Shouldn't you understand Jake's question when Jake asked you a question 20 minutes ago? You said, "I don't even know what you mean. It's irrelevant." Like, well, why wouldn't you understand what he means? If you know so much?
Your mic is kind of bad, by the way. I didn't hear the first part of that.
Well, someone said that celestial refraction was negligible, and I was questioning that because I trust the person who said it, so I wanted to get to the bottom of it.
Well, to the naked eye, I mean, how much can you distinguish with the naked eye?
Not much.
Yeah, like 15 arc minutes? No, probably not. Like I get what you're saying.
You can't ever answer that, Dyslow, because they won't tell you degrees of change come from your eye and what you see. They'll just ignore that and they'll just say arc minutes and yada yada.
That's not true.
It's no point.
It's the environment, Sincleanser.
Hold on, it doesn't come from your eyes.
That's what you claim because you think you can measure things with your eyes closed, friend.
You can.
And I just disagree with that logic. That's unsound in my opinion. But
if I have a whatchamacallit, let's just say I have a compass. Not like a fucking magnetic compass, an actual just
can we
drawing
not derail
compass.
this?
It's not
that's a whole
derailing
thing.
you.
I wasn't talking about any of that.
You got Sin. Yeah, you got Sin and Chief going back and forth with each other over a
Well, I heard you go back
non-argument.
and forth, and I didn't interrupt or mock you. So,
but look,
we're not talking about the ability to measure things with your eye. Yeah, no one's claiming that you can not.
No one's claiming you measured
use
anything.
6 months.
What are you talking about? If you see a star, right,
I'm
you're
saying
looking
you
with
guys
your eye,
never
right?
measured anything with the celestial data, or you never.
Are you
did any
looking with your eye? Are you looking with your eye with
When I measure
star?
something, I look with my eyes open. Yes.
Okay, yeah. No one's closing their fucking eyes looking at a star, bro.
Well, despite what you may think,
stop trolling.
You don't have to mock me. You just have to let me speak. Despite what you just said, I had a whole group of celestial theodolite people telling me they can do it with their eyes closed. So, whose side are you on?
Wait, really? Who said that?
Yeah, so maybe you shouldn't bark at me like you know what you're talking about, sir.
You guys,
don't have a point, Sincleanser.
Yeah, we either get trolled or we ask Sincleanser to keep himself on mute because this is just bad. Nobody said you're doing anything.
Why do you guys dismiss what I'm saying, though?
Because you just heard about this yesterday and you're just picking up pieces you feel like you control on. It's obvious.
Am I not welcomed here, Joe?
It's not about being welcome. It's about not destroying the conversation with fake trolling.
I wasn't fake trolling. I was offering constructive criticism to something that I think they missed.
Okay,
right,
nobody's
real discussion.
it's just, can we get back to something real?
Yeah, the real discussion is the refraction, right? And how everybody's like trying to calculate what the light is doing, right? And we have Dan telling us like straight up, this is like what he does. And he's making a point to say, no, you guys are trying to apply refraction where it does not belong.
Well, to
make
be
an
fair,
argument against something, right?
Well, Pure, to be fair, Danny did say that the most celestial refraction would occur near the horizon. And with the celestial theodolite, we are taking very, very, small angles near the horizon. But there's a reason for that, and that's because we want to show the difference between what a globe Earth would do and what a flat Earth would do, right? Because you want to have it near the horizon because that's when you can really see the difference, because you're supposed to have way more drop over distance the farther away you are and the closer you are towards the horizon. Like you can't really show the difference if you're at like 45 degrees. You know what I mean? Using stars.
What I'm trying to say is the amount of refraction that's people are attempting to invoke is just not justified, because all the experiments we see, right, are the documented experiments that we can go over all the data. It shows a pattern, right? It shows the light bouncing, like not like a little bit, like leaving frame. That amount of like dancing light, not a little shimmer, not a little twinkle, twinkle, little star shit. It's relocating. We're not getting that when we're looking at the stars, so we know that level of refraction should never be invoked, because we can never observe that. And when we can, we know, okay, well, now we really need to like kind of disregard this observation because it's some serious, heavy, super, whatever you want to call it, refraction going on. But if you're not witnessing that, like, you're not justified in invoking it. Because even though you're going through like these density layers, you're skipping the main density layer. You're not hugging the horizon where the most amount of refraction happens and all, and there's like this great level of turbulence. No, you're kind of like cutting right through it. You're cutting right through that layer. You're going into a less dense medium. And every medium you go through is less and less dense. So you're not going to get that level of refraction. So it's like, well, yeah, the star's relatively where it is. Unless what? You're like, what do you say? Like a degree or so off the horizon? I think Danny was saying.
I don't know if Danny's still there, but yeah, basically half a degree is usually the max when it comes to celestial refraction, and that's near the horizon. These observations are near the horizon, though, to be fair.
Well, they are, but they're not. They're like, fuck it. The angle of them is not, lined up with either whether it's a flat baseline or it's a curved baseline. The angle, the trajectory isn't, in line with that.
So why do all the
positions cuts right through it?
Why do all the positions have the same time then, or whatever? Why is it included at the same time for all positions, or whatever the F Jake has been saying for months and months?
Wait, why is it occluded? Because there's only one occlusion time, right? When it disappears, there's only one time when it disappears from the observer, right? The observer being
at one location.
No, at multiple locations now. There's been multiple locations now.
But the occlusion time is perfectly in line with what Stellarium says the occlusion time is. That's the part that I don't understand. And Jesse has come in here and he's shown that for these peaks, if you plug this into Stellarium, you compare it to the video, it correctly predicts the occlusion time exactly, which is when the star will be at the same elevation angle as the mountain.
And nothing to
So
do with
that's
the
what I don't
method,
understand. What even the whole point of the observation is, you could do this whole thing just plugging in numbers in Stellarium and plugging them into your spreadsheet, because
So how
the
do you
occlusion
critique your
time.
method? How do
I
you
don't even get
critique
what
your
Jake's
method?
saying.
Wait,
Could
someone
else entirely?
Yeah, could someone who wants to respond to that, like substantively?
Go ahead, Gio.
But Gio, get on them, Gio. See what I'm saying? They got a little thing. Help them fix their little thing that they saying, Gio.
Wait, you guys are calling on me? I was somehow.
Yeah, you're the one.
I was doing
iron
something.
and squash and shit, bro. They got little baby beef. I help them iron it out.
There's no baby beef. It's just if
is.
someone has a question about like what the cell theo is, like that's fine. I'm totally down to answer it as best I can. Good in good faith.
Keep trying to bring it about an apparent angle observed from a different location is not what it's about. That's the standard globular method that everyone
This is
uses.
from the observer's
Hold on, don't
location.
interrupt him, dude. Don't interrupt him. Let him finish.
Oh well, it's fine. Jake
It's the
should.
same.
He's addressing what you said.
It's the same thing you keep saying that I keep addressing it with, right? It has nothing to do with the method. We're using an observation of a time. In the examples I keep putting in chat, he's using an old school video camera, right? Say it's a black and white VHS. That's all you need to record. You can't actually see the angle from the star. All he can write down is the time. That's why he's got a chronometer with him. So the only observation is the time. As you correctly pointed out when you said in the spreadsheet, the only input from the observation is the time. Yes, the time. So that provides one angle, a singular angle. When you go to stellarium, that angle is the 232 put up in the white in the corner. And that's why the prediction of 231 is much closer than the globular prediction of 217. Trying to make it about a different, trying to incorporate what it looks like from the theodolite is not what you're using is a regular theodolite in your rebuttal. You just keep talking about how a regular theodolite is used. A celestial theodolite isn't a real tool. It's a conceptual method by which it uses the steps I just outlined.
Okay. So the thing you're saying, the angle it gives you, that also gives you the position because you'll have to be at a position along the line of that angle.
Position for everyone is the mountain.
You got to be on the hypotenuse viewing angle, basically, right?
Position for everyone is the mountain. When you use stellarium, that's the coordinates you put in, the coordinates of the mountain.
No. If you're trying to find the occlusion time, you put the coordinates of where the observer, where the camera is located in the stellarium.
So he's going that direction.
No.
See, there you go.
That's not the method. That's not the method at all.
We told you this multiple times. I'll say it again nice and clear for you, okay? If what we're trying to do is figure out which prediction or calculation is actually more accurate to reality in terms of deriving the distance, right? Then we don't tell stellarium where the observer actually is. All we're doing is telling stellarium what time and where and what time and what peak. That's it. And then seeing the star, right? Seeing the star.
That seems hard work too, though. But Jake's way should work too, also.
But the angle of the star is going to be different when you're on that peak than the angle from the observer location because of the 69 degrees, the 69 miles per degree of change on the spherical Earth as you traverse the surface of the sphere.
Also, just let it be noted that a theodolite has a maximum recommended use distance.
Yeah, it does, like 100 meters.
No, that's only for the range finding capability. Nothing to do with making angle measurements.
Which again, we're not.
Those limitations are only related to range finding, laser range finding built into the theodolite.
No one's making any angular measurements, so I don't know why you keep talking about that. So say, look, if you guys want to develop a different method and disagree with the results of our method conclusively, that's cool. We'll give you that. But to purposely confuse these two as if they're the same is getting exhausting after 7 months.
Well, I mean, you could use this method. You could use this method because there's no disagreement. Look, the observer where the camera is not on the mountain peak. It's at the guy's house or wherever it is he has his camera set up. And we've already plugged this into stellarium. And the time that it occludes on the camera is precisely what stellarium predicts for that location. So it shows that stellarium is accurate. You don't even have to go outside to do this.
All right.
You can just plug it all in stellarium.
Hey, Jake, let me ask you a question. I just want an honest answer, okay? Did the mountain peak occlude the star?
Yes.
Okay, so the method is basically extending that to the mountain peak, right? You're basically extending the line, forcing the line. That's what you're doing by using the occlusion time, right? Because once it's occluded,
the
right?
We know for the peak will be different because level is not the same at the location of the observer and the location of the mountain peak because of 1 degree per 69 miles.
Yeah, but it's not talking about that.
You cannot just extend an imaginary line through that peak and say, oh, if someone was standing on this peak, then the true unrefracted angle for the star's location is going to be here. That's just silly.
Jake, I don't hear them saying that though, man. You got to be somewhere in that, like along that. You have to be within that angle. They're telling you an angle, so wherever you go, it has to produce an angle from you, the baseline, and the peak to the star. It doesn't matter where. If you're putting yourself on top of the peak, the fuck does that have to do with anything?
Also, specifically including that in your prediction, we're specifically including it, which is why it's not correct. So that's our whole premise again.
Also, remember that Stellaris utilizes like refraction indexes at sea level, regardless of where you put it.
Yeah, so a 2000 elevation change for the pressure coefficient and a GG Bennett celestial refraction amounts to how many arc seconds? Are you familiar? Do you know?
Arc minutes. But yes.
Arc minutes. Yeah, arc minutes. Yeah.
2,000 foot in pressure would change it by how much?
2,000 foot in pressure will lower it by about like it'll lower it to I think it was 11 to 10.8 psi.
Changes the coefficient when we're trying to apply it by how much in this prediction?
About 2.1 like minutes.
2.1 arc minutes.
Yeah.
Right.
And that
so
is
you're
that
still missing. You're still missing.
Does that bring 219 closer to 231 than 231?
Yeah.
No. So
yeah.
So that would be 221 to 231 compared to 232. In which case, 1 arc minute for the flat Earth prediction would still be correct, right?
No.
And then you don't agree with math. You want to fight with triangles?
Yeah, I'll fight about it.
That's all right. I'm good.
No, listen. If you have
because when I looked at your formula and it's somewhere in there, like somehow, like whoever set it up just didn't do it right, where they calculated how far off they calculated how far off it would be, and it said 2.1, like arc minutes led to 4,200 feet off. That math don't work.
The distance.
Yeah, the distance doesn't match with the degrees. So somewhere somebody made a big fucky wucky on the equation when they were plugging into Excel of all things.
Okay. Let's say the Excel spreadsheet is fucked up. It's being worked on, right? But
yeah,
conceptually, right? 221, you have that as your angle, right? That's your hypotenuse. Then you have the height of the mountain, right? There's only one height of the mountain, right? If you were going to derive the baseline of the triangle, okay, you would have a different distance if the angle was 231 versus 221. Do you agree?
231 versus distance or
distance.
Yeah, distance
because you have the same height.
Distance would be different.
Yeah, the curve baseline would be different.
Yeah.
Yeah. So the baseline would be different. So in reality, which is closer to where the observer actually was?
I would have to check on to see what the actual data is, but from what I'm currently seeing, y'all's equation is fucked up, so I can't really trust y'all's numbers.
Okay. Well, the point is that's what we're doing. We're comparing the distance.
So you're using a fucked calculation to compare with another fucked calculation. Congrats.
No.
Yes.
You're just saying that. You're not actually saying.
No, you even addressed the issue that I brought up. Not even was it a minute and a half ago.
Okay, could you show us the discrepancy?
Yeah, we looked at it the other day. Somebody had
I know, but since you're on it right now, could you show it? Because right now,
yeah, let's actually go over it. Because let's fix it together.
Listen. I'm trying to look at y'all cells. I can't even tell what this shit is referencing.
Okay, so you don't have the discrepancy. Just in the combo, you assumed there was one, and you just started
we looked over it here 2 days ago,
making comments about it. But
when I was on here 2 days ago, we looked at it, and
can you show the discrepancy?
And Ruhif even brought it out. Yeah, just a bit. Give me a second.
All right, just come back if you could show us that, because then we could actually look at it.
Yeah, that's fine.
No, Ruhif tried to go over it with y'all 2 days ago, and he got removed from the server.
He did not get removed from the server, so don't make that up.
Okay, well, he got kicked by somebody who didn't really butthurt. I think it was Adam.
Chief, you just say stuff, dude.
Yeah, when they're hosting the event. Yeah,
sorry,
but hold on. That's not. Yeah, but when they're hosting the event, when anyone hosts an event here, they can run it how they want. So when it's open panel, it's a little bit different. But when they're running an event, it's kind of like like a call-in show when the host can just be like, okay, and just dump the caller. In a similar way, if you're running an event here and you're hosting it, you choose the content. So that's fine that he was finished with Ruhif and they moved on. He didn't get removed from any servers for that. But go ahead.
Yeah,
Toby.
and that's also kind of an unfair characterization because they did let Ruhif talk for it was about 45 minutes. Ruhif talked for a very long time, and it's it's after a certain point you can't let someone repeat themselves for longer than 45 minutes when you're trying to do a show.
It becomes circular and unproductive.
At some point, you have to answer the questions he's asking you.
Right, but you do agree that the method, right, is actually comparing the distances, right? Because you only get one angle, right? One occlusion angle, and that the height of the
Obstruction
mountain is,
angle.
or, okay, fine, I'll say obstruction, whatever.
Yes.
You agree that there's only one time where that star gets obstructed by the mountain peak. You agree?
Yeah,
with
sure.
that?
There's only one exact time.
Exactly, right. So that's the angle. Bam. Then you have the height of the mountain.
Well, how are you getting the angle?
What do you mean how? So that corresponds to the angle in stellarium, which is based off of the 15 degrees per hour shift.
No. How are you getting it to the angle of the observer?
But here they're putting in the angle in stellarium that you would see if you were standing on the mountain peak.
Right. Because
Yeah,
that's what
so-
was occluding. That's what was obstructing the star.
But it wouldn't be
No.
the case.
What
That's
do you mean that
where
wouldn't be the case?
this whole thing doesn't make any sense. Because
Okay,
we
so-
know that angle, the angle of that mountain peak is going to be different
Oh, I
at
see.
any instantaneous moment that you took that angle measurement to the star. It's going to be different from the angle peak than it is from the observer location 50 kilometers or 50 miles away.
I see what they're doing wrong. This is so funny.
So the true position of the star, according to stellarium, from the observer, is 2 degrees and 4 arc minutes. You see why we don't use
observer
that?
location?
Yes.
So what was
Before any
the
refract-
so
before any
what was
refract-
the what was the angle that they measured to the star?
What was the angle?
Yeah, what was the angle that
measured
y'all
the
measured
star?
to the star? What was like the what
So
was
from
the
from the peak to the star, there.
No, not from the peak. I'm asking from the guy that went out there
From
with
the observer?
Yeah.
Are you saying from the observer to the peak, or
Yes.
the observer to the star?
The observer, well, again, the peak would be where the star is. So when the observer looked at the peak from wherever his ground position was, which was not the peak, from what I understand, what was his viewing angle?
That's not part of the celestial
We
theodolite.
don't know. All we know is the time.
Okay, so all you know is the time, and yet,
Mhm.
okay, this is just a whole bunch of nonsense then.
No, you're basically using the intersection point between the observer and the star, and that being the peak, right? Because that's what actually obstructed the star. Right? It's a physical intersection point. We're basically connecting the ground to the sky by using the obstruction. Okay? We're taking a snapshot in time. Then you're transporting the observer to the mountain peak because it's the exact same time.
To the mountain peak.
Because you want to see what the angle is to the true position of the star. If you were going to use the refracted position, it'd be 246, which is way too much. Way too much anyway. Doesn't even make sense. And that's what Danny was saying as well. Like to use celestial refraction, right? To raise the star, between the observer and the mountain peak, and then from the mountain peak to the star again. Like if you're going to use refraction twice, it doesn't make sense. Why would you need to do that? The only reason why you need to do that is to actually show that this is
Because
the
there's
globe.
two different observers. So refraction is going to be different for both of them. This is easy. It's as simple as that. I mean, if you can just go out there, if this guy actually went out there with a theodolite to record the time, why not also go out there with an angle measuring device? Unless you just want to fuck with numbers and be dishonest.
No,
So
dude, you all right.
Okay, go ahead, Rick.
I just don't understand why they don't. Like, why do you need a theodolite? You don't need something to measure the angle. You're looking at the timing between the star and the peak of the mountain. No theodolite needed, dude.
Yeah, I mean, you could even
of the
say like the
mountain.
play on words. That's why it's a celestial theodolite. You don't use a regular theodolite. It's a celestial theodolite. That's kind of the idea.
I think it's a great name,
I think
but the name
partly
seems to
behind
confuse
it. Yeah,
people.
You could just use a bubble sextant.
it's like you're using the mountain as your crosshairs, and you're using the timing as the timing in relation to when the stars are at their zenith at 0 degrees of Aries, and then with the 15 degrees per hour, because we know the stars move 15 degrees per hour. So you're using a very you're using this is like an internal timing technique to where you're actually using. You don't have to deal with any refraction of stars or where they're jumping around. you know where they are at the 0 degrees of Aries, measuring their zenith positions, which is what is used at the beginning for this, to where there's very minimal refraction, if not almost none, when you're looking straight up, is the component there. And then when you do a lot of those as well, they've been done repeatedly to where you get a consistency. And from that 0 degrees of Aries point out, 15 degrees per hour. Then when you get the timing, you're using essentially the mountain as a crosshairs to get the timing. That timing is then going to allow you to derive the actual baseline distance. So if you had two teams, globe versus planar, and you only gave them this limited information, meaning you couldn't give them all stellarium and all that. I'm just saying if you gave them well, you could maybe, but that's another. I'm just saying you'd have to decide what tools you would give them. The planar side could actually properly derive the distance, and the globe side could not.
I'm confused why the angle wouldn't matter if you guys are doing trig with straight lines, though.
Well, I would also point out that we have confirmation on the internal consistency of the angle because we can derive our distance to the mountain using purely the angle and the height of the mountain.
Right. That's another interesting quote unquote coincidence that Ruhif said way in the beginning. He was like, "Oh, it's just a coincidence that it matches plain trig every time."
Every time?
Yeah, he claimed that it was just a coincidence from Mike's house to his peak in that area. He claimed that was a coincidence. Then when we started getting other locations and also confirming that, then he started go on this complete, now he went from it's not a coincidence to your method is rubbish.
I guess he looked into y'all's method and he came up with a better one.
God, the arrogance in your voice. Dude, I don't know if you guys remember when Ruhith, all the Globers, threw Trulin under the bus because mathematically he proved that you can create a mathematical construct of any model of the shape of the Earth. And then Globers, they just pretty much all threw him under the bus with his math. Even though this guy was like a math genius, he created a model, had a website, everything to back up his claims. But they just
Trulon or something like that.
Yeah, Trulin. Yeah, Trulin. They threw him under the bus so fast, dude, because he mathematically proved that you can just take this data, these points, and you can create any shape you want. It's just a mathematical construct. And these Globers, they just can't grasp that, dude. They're so lost. They're just
you can take all the angles you want and make whatever shape you want.
APOC, hold on, APOC. Can I ask you a question, APOC?
Yeah, what's up?
Are you saying that the celestial theodolite group, are you saying that they are a flat Earth? That's a flat Earth group?
I think they all stand on that side, yeah.
I don't know if they are actually all flat Earthers, though.
You mean some of them might be geocentrists, maybe?
I think they're more prone to go with ether, whatever,
Sincleanser,
than anything.
I know it's been a couple years since you've been around. Are you familiar with ether cosmology?
Well, I agree. Some of it I agree with. Some of them I think they're just reifying the globe.
Do you know about they have a server, channels? Do you know about ether cosmology, the servers and the channels?
I was invited before I took a 2-year break to those servers. Yeah.
All right. Well, I mean, you're asking. I just didn't know if you even knew who they were. But
yeah, right before I left Flat Earth, the ether movement was really gaining a lot of traction. And they kind of invited me to a lot of that stuff, but I left a lot of that because I was leaving the whole discussion for a couple of years.
All right. I was just asking because you were asking some of that. Okay,
they're all flat earthers though. So,
well, they're trying to. Well, I'm not going to speak for them. It's just the old flat Earth arguments about refraction were kind of our game-winning bread and butter, but they're getting rid of refraction to prove the flat Earth, which is kind of cool. But they're going to step into the globe math, and they might get lost. Is my only thing.
I see what you're saying. I mean, I was pointing out too, using stellarium. They're doesn't that use a globe? And stuff I know.
That's what I'm saying. The Globers are going to have a field day when you're using globe reification.
They already have. I mean, I've heard it on other other areas and other conversations.
No, you don't need to use the globe though. You don't need to use that. You don't. It's not about. It's really not about refraction, and they're not ignoring refraction either. That's not a fact.
But Gia, my whole thing with them is that they're using a reified globe model to prove the flat Earth, and that's just a bad start already. So stellarium is why the Globers will always laugh at that type of argument, I think. That's just my own opinion. I don't know if that's... if you were thinking as if you were a Glober, you would say, wow, these guys are in stellarium, reifying the globe to prove flat Earth using a globe, right?
Wow, they got a model. Wow. and it's pretty accurate. Wow.
Realization of the implication of what we're talking about. What they do, instead of absorbing the position or saying anything is wrong, is they immediately change everything about the proposition so that they can they're like, hey, well, listen, you know what, this is stupid, and why would we use a whole different method when we can just look from the house to the mountain and make a prediction using a theodolite angle and accommodate regular refraction, and boom, globe's right every time. And it's like, oh, so you want to just look at something and do nothing with the celestial theodolite providing mutually? Like, they'll just immediately change it to a regular observation and pretend like it was that the whole time. It's been really, really gross.
Testing 1 2.
Lower
Right.
it.
Beautiful,
Lower.
man. Well,
I don't know. Oh, hold on.
Much better. You're good.
Yeah, now you sound good.
Yep.
What were we just talking about? Finding your position with the old mountains, or
Well, he was asking, hey, when the globulars realize the implications of what we're talking about, how do they accept it?
Yes.
Yeah.
Yeah, they don't. So what they do is they change the argument. They argue something else. They say that we're doing a straw man. They say that what we're doing is rubbish. You know, they just ignore it loudly, right? Because it's not about why they're ignoring it. It's just about how loud they can do it. It's like there was a perfect example of that today. Professor Parks put out a video and was like, I disagree with this wholeheartedly, even though I know nothing about it. And even when corrected on my assumptions, I'm still going to double down and say, no, it's wrong. And that was like the whole premise of his 8-minute video. And then like other people watched that and went, oh, I'm so relieved that you looked into this now and I don't have to look into it or consider it because you did. And you know, like, it was so sick to read the comments to be like, how much these, like, no one's going to think for themselves. They literally went there, watched him talk about how he doesn't know a fucking thing about it, but doesn't like it and how it must be wrong, therefore. And people were like, dude, totally agree. Thank you.
That does seem to be the case with this celestial theodolite situation here. Pardon me.
I'm going to start calling it the sidereal surveyor, see if that catches on. And then people are going to start selling sidereal surveyor devices or whatever.